Hey everybody, this is Larry. This is Leetcode Daily Challenge, day 6 maybe. Hit the like button and subscribe and join me on Discord. Let me know what you think about today's forum. I am here in Ushuaia in one of the glaciers, and you can let me get up a second. This is all these snow behind me. So I forgot my sunglasses actually, so I'm like squinting a lot, but you know what I look like because I'm on TV. Anyway, and this is my reel that I was looking at, and yeah, let's go. Hey everybody, this is Larry. This is me in Ushuaia, as you saw in the intro. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem, day 6 of the Leetcode Daily Challenge. I don't know. Not my computer, but my internet's been kind of erratic today in the new thing. In moments I have very fast internet, and you saw it load really quickly, and then now suddenly, like I just have low ping. I don't know if it's just like some weird. I don't know what's going on, but yeah, I'm very tired today. I had 5 a.m. flight, and I just haven't slept since. So let's get this problem, and hopefully it's not too bad, and let's get to it. Today we have, also I hope you enjoyed the intro. I'm obviously in Ushuaia. I'm going to do a hike tomorrow morning, so we'll see how that goes. Today we have 3578, count partitions with max min differences at most k. You're given an integer array nums and an integer k. Your task is to partition nums into one or more non-empty contiguous segments, such that in each segment the differences between its maximum and minimum elements is at most k. Okay. Return the total number of ways to partition nums under this condition. And there's something about mod. Let's do the mod thing right now. Right? Okay. So then now we have the mod. What are we doing? We're doing partition. If k is equal to 4, what does k equal to 4 mean? The max and the min. Okay, that means that right? Okay. Let's think, right? So looking at the constraints, the numbers itself does not lean itself to some sort of DP, or at least not on the range of numbers, right? So that's kind of the first observation I would have. N is okay. I mean, probably an n log n. I don't think n squared will be fast enough, so we definitely have to think about that. Okay. Yeah, okay. So now we have to count, right? The way that I always think about these is try to think about it with contributions, and these things are hard, even though this is a medium, so I might end up taking a while, which is why I'm a little bit not happy about it, because I want to just go to my bed and lie down kind of thing. But okay. Also, I should charge my watch. I mean, I think for each number I ask, sorry, let me think for a second. I think one thing that I would say is that, okay, if this is the last thing, then, but this is more of a partition, so it's a little bit different than my usual, like counting the number of subarrays or something like that. So that's not quite how I think I should think about this one. Okay, so maybe for each number we can, well, maybe I don't know this one. I mean, I probably could figure it out. I mean, I obviously do at some point, but I don't know. Because okay, so one goes to 3. Is this subarray? Okay, contiguous segments or subarray. So then it is just about, I see. So it's like an n square e thing, but you have to be a little bit careful, right? Because basically, okay, let's say what is the most naive thing that we can do? Well, I mean, the n square solution would be something like, what would the n square solution look like? I think maybe we start with that, right? So we have maybe then index, and then we do a for loop over the index, right? Yeah, okay. Let's try it out. I mean, I know that this is not going to work just to be clear, but I want to write it out so that I can at least get a sense of, and then maybe play with how to get a feel about this problem, right? So we have something like this. We can return 1, right? Otherwise, yeah. And then we just kind of basically starting from index. Let's see how far we can get and make a partition, right? So something like, min is equal to num sub index. Max is also equal to num sub index for now. And then now we have just for, I don't know, variable names are tough, so I'm just gonna, from index plus 1n, right? So then now, and technically maybe you could say index, right? So, I mean, this doesn't do anything for the first loop, kind of, right? A lot of construction going on. I don't know if you can hear it, but it's, my apologies. We got a 940? What are people doing? Okay, anyway, right? Then now, if max minus n is less than equal to k, then now this is a good segment. And keep in mind that, this spread, if you want to call it, will only get bigger. So our else statement would be just to break, right? So we have to do a total, right, for a total count. Then now we just try, right? So then now we go from index to I inclusive. So that means that the next number is going to be index, I plus 1, right, for the number of count. And then that's it. And then we just return total. I mean, of course, there should be some mods in there, right? But yeah, of course, this is going to be too slow, but I just want to see it real quick just to see if it works. And then maybe we can play around with it a little bit. Okay, so I mean, in a way, it doesn't work. Which is surprising, maybe. I mean, no, oh yeah, because this is index. Whoops. That is why when you call things index and I, you confuse yourself. Okay, so with Gucci, with the correctness, I would have to guess. But now, of course, we have to try to do it faster, right? Because this is just not going to be fast enough, as we established, right? So, So then now, I guess the way that I would think about it, right, is that I'm trying to bring up my drawing thing real quick. Oh, I still have my drawing thing from yesterday. Should have charged my watch while I'm doing this. Okay, right, and then the idea here is that, okay, so we have a DP array, right? Oops. Yeah. Whatever, okay. We have a DP array, right? I wish I could draw better than this, but I'm using my fingers. Whatever. Right. And then the idea here, the way that we wrote our DP is that, what's the answer to this one, right? Oh, jeez. This is so hard. What's the answer to this one? Well, the answer to this one is equal to the sum. If you kind of look at the code real quick, right? It's equal to sum. I'm trying to bring it back. Equal to the sum of say, I'm changing the color. Say this one, this one, this one, dot dot dot, all the way to some point in which it cannot reach, right? Because then now the spread is too much. Okay, right? Of course, this part, if we know what this point is for every starting point, then this is, I wouldn't say it's easy. How is this a medium? Wow. Am I going nuts? I'm trying to think. I mean, what? I mean, I know I could. I mean, I'm doing it. It's not difficult for me, but it just doesn't feel like a medium, which is kind of nuts. But in any case, yeah, the way that you could think about it, right, is just by, well, the way that you would do it is just calculate backwards. Let me calculate backwards, and then now when you calculate backwards, then now you have prefix sums, right? Or you have, I guess in this case it's a suffix sum, but you have the idea is that you just have a prefix sum, a data structure that's similar to prefix sum, so that you can answer this in O of 1, right? So if that does not make sense to you, my apologies is first, but that's because it's a very advanced, maybe not very advanced anymore, but still not a beginner or even intermediate concept. I would say this is an advanced idea, an advanced DP. But in any case, once you visualize it like this, though, I have it on screen. Okay, just want to make sure. Then now you can do this to the O of 1, and if you do this O of 1, then you're Gucci, right? However, the thing that I said was that this only if you know what the endpoint is for each item, right? So then now, like for each beginning index, we have to find how far to extend, right? And then now, how is it already 10 p.m.? And then now the next question is, how do we figure this part, right? Well, you probably could do it with sliding window, if I have to guess. Because then now, yeah, I guess that makes sense, right? Because then now you start with, here you go as far as you can, right? I'm changing colors again. So you start with the first one, you go as far as you can, dot, dot, dot. And then now the next cell is probably just going to, is you go to use subtracting the first cell and then also try to go as far as you can to the right, right? So, okay. So I think that's it. I think we have all the components we need for this problem, even though it's a ridiculous problem for a medium. I'm kind of shocked that this is a medium. I mean, like, I don't know. I mean, yeah, no, I don't know. It's just hard. I think that's the idea that I would say. I mean, it's not like, I mean, I'm doing it. It's not impossibly hard. It is just not a medium, I don't think. I think if you label this as hard, I would not, like, I'll be like, okay, that makes sense. Okay, so then now we have to do the sliding window to calculate how far to extend, right? Yeah. So maybe you have a left, 0, 0 for right in range of n. This is how I write it. I don't know how that get out. And then we have to kind of store, maybe just call it like reach. Yeah, whatever, yeah. And then now you're trying to get the max and the min of a window, so we can just use a sorted list. Yeah. Right? And sorted list just maintains, well, a list that's sorted. So you could add and remove, right? So then now we add num sub right. So then SL of num sub SL dot add num sub right. Right? And then now while the max element minus the min element is greater than k, then now we have to slide the window. So left increment by 1, but before that we remove num sub left. It's sorted? No, yeah, no, it's not. Dupes are fine. So the yeah. Though I mean, this is fine, but I think I did this wrong. I mean, this is fine, but I think this is like a little bit annoying because because from this we can get from the right side, we get the left side. But actually, I want the other thing, right? I don't know. Maybe I'm just not thinking today. Because we're on the left, so okay, so fine, right? So then now, for left in range of n, and then now, sorry, right is equal to 0, right? So then while so okay, so now we want to say while right is less than or equal to left, we just add it in. So then the right is exclusive, and now, and this is why you have invariance and understand it. And now right is inclusive or exclusive, sorry, exclusive. And then now yeah. This is weird. Am I doing this right? This is fine. All right, and then now, while SL1 minus SL of 0 is less than equal to K, then we add num sub right, and then we increment by 1. So then now it extends until the right is until this is bigger. So then now that means that reach that append right. The idea being here, well, you have to. The idea here being that this is the last one that you cannot reach, and then now we remove left for the next one, right? So then SL that remove num sub left. Okay, this looks a little bit wonky because that's not the way that I usually do it. So let's print out reach real quick, and then we'll just manually check it. Okay. Oh, I guess right has to be okay. I mean, we didn't change it, so okay. So 255. So 9 only goes to 2, which is true. 4 goes to 5. I guess that's right, and that's right, and that's right. So I think that's right for example 1. 334, 333, because everything. No, everything. No, the 3 threes. No, that's wrong. Because 3 should not reach to 3. So we add right. Oops. Something's wrong here. Zero, 3, 3, 4. True. Why is that 3? Did I change K by accident? No. Okay. 0, 1, 2. No, it should go to 4. It adds 4. Oh, it adds 4. And then it increments by 1. And then now so right is the first number. Is that true? I feel like there's something weird I'm doing here. I'm off by 1 somehow. It's basically, that's why I usually don't do, or I don't know. Maybe I just don't usually do it this way. But okay. So basically we want 3, we go to 3, we go 4, right? So we add it, increment. So I thought that would have to increment first. But that doesn't make sense. I don't know. Because then now the state is that, okay, maybe we'll just write now. Now it is too far, so then maybe we just kind of SL dot remove num sub right -1, and then right. I don't know. Does that look weird, right? If right is if I guess we could do something like this. Okay, and then now maybe that's right. Let's double check this. I mean, this is now 223, which is I think what I expect. But man, I'm so bad today. One. So 9 goes to 1. Okay. This goes to 4. Is that right? Oh, it is true. I think I had it wrong before. Actually, now this is actually right, because then now it goes to. Okay. Okay. So I think now we fixed it. If not, system test will tell us, right? So then now, how are we doing it, right? So then now, instead of using this for loop, we go, okay, well, we want total is equal to, let's just say, well, we want to say we want the sum, or not the sum, but we want to basically cache this for loop in a way, right? We want to go sum of for loop. Let's just name it sum 4 from index to reach sub index. Is it reach or that -1? Okay, so if it goes to 1, then it should not be inclusive. So it should be just -1. Return total, right? But yeah, actually I think that's it, right? In theory, we just have to figure out how to write this, right? And then now write sum 4 left, left, right? Then now, as we said, right, this is just going to be a suffix sum, which is a prefix sum reverse, not I don't know, not anything else, right? So then now maybe we have, we'll just name it return. I mean, it's going to be, I'm trying to think, but it's going to be like something like suffix sum from left. Which one is the bigger one? I guess so. Something like this, right? And the way that you could kind of think about this, and the way that I'm thinking about it right now, though it could be wrong, is just, yeah, looking at something like this. I want, you know, let's just say we are here at, actually, let's just say we're here in the 3rd cell, and we want to get this range. Then that means that we want the sum of all these numbers minus the sum of all these numbers. Oops. Right? That's kind of the idea that I'm trying to reach, right? Yeah. And actually, I don't think we need to cache this, because this, I think by caching this, actually might lead to timeout. You actually have to not cache it. Actually, I don't think that's true. As long as you don't do something stupid, because it is the same for every index. Okay, and then now we just have to write suffix sum of an index, right? And that is equal to f of index plus suffix sum of index plus 1, right? There needs to be a base case, which is if index is greater than or equal to n, we just return 0. And this should be good, though I think this is a little bit off, right? Because sum 4 goes to index, and then index eventually calls itself. No, oh, I see, because in this for loop, it actually skips the I. So actually the sum, it goes to, yeah, maybe something like this, actually. I think that's actually more precise. And that's it, hopefully. Maybe you have to add some mods here, but we'll take a look. Well, 0 is probably not the right answer. Maybe we just return 0 on everything. But why? We don't get it. Oh, because of this. Whoops. No, that doesn't make sense. Oh, yeah, because this never goes to, has to be, it's greater than n, because if it's exactly n, you want it to return 1. That's a little bit wonky, actually, but okay. So that looks okay, and every complexity here is linear-ish. So, I mean, other than the sorted list part. So I'm going to YOLO submit. I'm not worried about timing. I'm still may be wrong though. Very easy to make mistakes on this one. But this is a ridiculous medium, correct or not. How long did I took? 24 minutes. I mean, I know that I kind of slowed it down to explain, but it's still a hard one, right? How did past Larry do it? Probably by, that wasn't that long ago. I guess I just don't have good memory anymore. Oh, I did it with, okay. Well, that's the wrong answer one, so maybe that's not right. Why does that open here and not the other one? Okay, so, oh, I mean, okay. I mean, this just kind of, wow, this is, past Larry did it a crazy man's way. But I mean, it's still the same idea, but we used to use a mono stack to see how far you can reach, which is a thing for range, which makes sense for the max and the min, so that you could get the range. So you have a mono max queue and a mono min queue to reduce it, so that in that case it's linear, so it's even cleaner. But we didn't do it that way. If you want to watch that video, watch that video. We did it this way, and this is going to be linear. This is n log n, sorry, because we have sorted list. But everything else is linear, even though it looks a little bit wonky. We don't need this. But yeah, you saw how I converted to sum for. We just have a for loop. We summed it over thing, and for that, we just use a suffix sum, which we already know, which is more prefix sum than anything suffix tree. So I hesitate to kind of use that term. And then after that, the suffix sum is just what it sounds like, right? Just, yeah. Okay. There's a lot of light outside, which is crazy, but it's 10 p.m. That's when sun is setting. I am tired. That's all I have for today. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.